All right, so for our next example, we're going to take a look at the area under cosine on that same interval from 0 to pi. Our first example was the area under one hump of sine from 0 to pi. So let's compare that to cosine. All right, so what does cosine look like? Well, cosine starts at 1 and then goes something like this as we travel over to pi being our last input. So it looks like we've got some area above the x-axis and then some area below the x-axis. All right, so we mentioned last time that there was signed area. Area above the x-axis counts positive and area below counts as negative. Well, let's just use, before we dive into that and really think deeply about that, let's just do this as an example of the fundamental theorem of calculus. So this integral, the area integral for this, I'm going to say A for area equals integral from 0 to pi cosine of x dx. And so this is the derivative, f primed of x, cosine. What is cosine the derivative of? Well, so the integral from a to b is going to be f of x evaluated from b to a. So cosine is the derivative of sine of x. And we're going to evaluate sine of x from 0 to pi. So top minus bottom, this means we're going to have sine of pi. Sometimes I like to put them in big parentheses to show top minus bottom. Sorry about that, screen jump. F of b minus f of a. Okay, so we've got sine of pi minus sine of 0. Okay, so sine of pi is 0 minus sine of 0 is 0. That thing doesn't have area of 0, but we've seen it positive and negative, and you're looking at it's symmetrical above and below, so it should work out to be 0. But let's do this again, but this time let's split it up. Okay, so ready? So we're going to attack this thing again. I think we have, yeah, there we go. So this time we're going to do it again, but this time we're going to split it up into two pieces. So drawing the picture again. Let's see, green above, red below, just to use some colors here. Okay, so what happens in between there? Where does it cross the x-axis or the theta axis, the angle axis? Let's call it the angle axis at pi over 2. So we are going to take this thing and use some properties of definite integrals. Well, we're interested in the area integral being the integral from 0 to pi of cosine of x. Well, we just saw that that does not give us, because I'm not asking about signed area, I'm just asking for actual area enclosed under this curve between the curve and the x-axis. So cosine of x dx from 0 to pi. Well, using the properties of definite integrals, we can split this thing up into two integrals. I could do the so-called green integral, the integral above the x-axis with area above the x-axis from 0 to pi over 2 of cosine of x dx. And then we could add to that, because of the continuity of the definite integral, or additivity of definite integral over continuous intervals. Fancy way to say that. And this time we're going to look at the area below the x-axis. And this time we got pi over 2 to pi. Let's see here. All right, and then cosine of x dx. I'm sorry, cosine of x dx. All right, same logic follows. So we're looking for the integral of these. So how do you evaluate the integral of cosine? Well, cosine has derivative of what? Or is the derivative of what? Cosine is the derivative of the sine. So we're going to take sine and evaluate it from pi over 2 to 0. And then we're going to add that to, well, again, cosine has the derivative of sine. So this integral becomes sine evaluated from pi to pi over 2. All right, so writing that out, what do we see? We see that we have in green sine of pi over 2 minus sine of 0 plus sine of pi minus sine of pi over 2. We're going to get the same answer here, but you're just going to see kind of why. All right, so what do we get here? Sine of pi over 2 is 1. Sine of 0 is 0. And then sine of pi is sine of pi is 0 minus sine of pi over 2 is 1. So what we see is we end up with positive 1 minus 1 gives us our 0. But what this actually kind of translates into is we can look at this and say, okay, this area equals positive 1. This area, and I'm going to put it in quotes because it's signed area, equals negative 1. So if you actually wanted to answer the true question of this is, you would just take the absolute value of that and say, okay, the signed area is the same as the area positive, just ignoring the sign. And you could see that the actual area trapped by cosine of x between the x-axis is equal to 1 plus 1. We're going to stop this example here.